let's start from power electronics. So we kind of want to have a brief review of power electronics, and then we look at the concept of modeling, concept of control, and the related knowledge, more like a review of knowledge that you have learned before in chapter 1. So we are going to review power electronics, review control, knowledge control, what you have learned about control. Now here is a picture showing the structure of a power electronic converter. Or there are different names for power electronic converter. There is another name which is called switching converter. Let's see. Can you tell me the other names for power electronics converter? Power electronic converter. There is another one which is switching converter. What else? Sometimes it's just called power converter, right? Or electronic converter. Or simply just converter. Because when we are talking about the electric power engineering, when you say converter, then everybody knows we are talking about power electronic. But in other areas, converter may be referring to other kind of converters. For example, in the signal processing, there is analog to digital converter, or digital to analog converter. So there are different meanings. But in here, in electric power engineering, when we say converter, then nobody has any misunderstanding. It's all about power electronic converter. Now, come back to the fundamental question. So what is power electronics? Anyone? I suppose most of you have learned a power electronics course before, right? So you should be able to know or answer this question. Nobody? As I mentioned, don't be afraid to make mistakes. Yes?
It's a truth that converts the form of the power. Maybe the form is applied AC, that the power of the convert to AC.
Okay. Any other? Yes.
Control and conversion of power, electrical power.
Control and conversion of electric power.
Using semiconductor devices.
Using
Semiconductor devices.
some power, some conductor device, semiconductor device. Okay, so let's combine this thing together. My definition would be power electronics is the electronic, because we're talking about electronics. So it must be kind of electronics. So my definition would be power electronics is the electronics applied to the conversion and control of electric power. The reason why I didn't include using semiconductor devices is that theoretically, it could be implemented. The conversion and control of electric power could be implemented not based on semiconductor devices, it could be implemented by other types of devices, electronic devices. So the simple definition is power electronics is the electronics applied to the conversion and control of electric power. If you really want to extend that definition with more details, you can say right now most of the power electronics technology is implemented through power semiconductor devices. Okay, so that's the definition, and there is also discussion in the screen on this slide about the what you have just mentioned, different forms of conversion from DC to DC, AC to DC, or DC to AC, or AC to AC. Okay, fundamentally there are 4 different types of conversion. From AC to DC is also called the rectification. Then the inverse direction conversion from DC to AC is also called inversion. Usually, for these 2 types of conversion, the students feel very comfortable to understand. And AC to AC is a little bit more complicated, but still understandable, because it might be regarding the conversion of different frequency. Okay. AC could be at different frequency. Okay, could be at different frequency. Okay, so therefore, we could be converting one frequency AC to another frequency. AC could also be actually at different amplitude, okay, even when they're having the same frequency. The input side, output side, when they're having the same frequency, you can also convert their amplitude. So if you realize that, the conversion can be actually adopted to convert or change amplitude, then it's easier also for you to understand DC to DC. Although both sides, from input or output, both sides are DC energy, but they could be different in amplitude. Okay? So that's the 4 types of power converters. And here's the structure, the usual structure of a power converter, where you have here this the center block usually is the what we call as a main circuit. Let me put some Chinese terminologies. Okay, there is also a terminology system in Chinese. That was also a very interesting thing. It looks like, if you look at scientific or technology terminologies, everything is actually for most of the language, when they're discussing scientific technology things, then everything's in English. Everything in English. So there's a English systems of scientific terminologies, but there's also Chinese system of terminologies. That was probably the only 2 systems in the world. Main circuit has another name sometimes, power stage. Power stage. or power circuit sometimes. Based on these names, you can understand that we're talking about this center block. It's actually talking about the part of the circuit that is dealing with electric power. That means the voltage of this part could be very high. The current flowing through this part could also be very high. Okay. On the contrary, this part is called controller. And therefore, that means this part, the controller part, is only dealing with small values of voltage or currents, which only are used to carry information. Okay. So that's the difference between the power stage and the controller. And then in this picture, there is a explanation of the relationship between the power stage and controller. You can see the controller is really taking reference. Reference has also another name. This is what I don't like about engineering and science. We usually have too many names for the same thing. Reference has another name, commanding. Or sometimes this is called given value. So the controller is really taking commanding signal and then send out the control signal to power converter main stage or main circuit, so that the main circuit will be operating following the commanding signal. But very often, we also need to measure the signals in the power stage. Therefore, we have feedback and also feed forward. Okay, feedback and feed forward. Which is used to measure signals, measure information in the power circuit. So power circuit not only handles power, but also itself carries some information. So therefore, in order for the controller to know what happens in the main circuit, there is very often measurement circuit to implement either feedback or feed forward. Now, let me ask a question. What's the difference of feed forward and feedback? I suppose also most of you have learned a course before, like control theory, or a course regarding automatic control. So what's the difference between feed forward and feedback? Yes.
So in feed forward, the input signal will be fed into controller, and for feedback, output signal will be fed into controller.
For feed forward means feed forward means when we measure signals from the input side. The input and output is based on really the direction of power flow. We are the power converter taking some power from the input side and sending the processed power, controlled power, or converted power to the output side. That's input and output. So feed forward means the measurement of signal from the input side, and therefore feedback means the measurement of signal from output side. Is that true? Looks like true. At least based on this picture. This picture draws like this. When you take measurements from the input, that's feed forward. Measurements from output is feedback. But is it true? What's the definition of feed forward and feedback? Any other answer? No answer? And I would be questioning, how did you learn your control theory course? Yes?
Feed forward is the stage before we apply our control action, and feedback is the stage after we apply our control action.
Okay, so his answer distinguished feed forward and feedback based on the location of control. If this is the measurement is taken before the controller, it's called feed forward. If the measurement is taken after the control has implemented, it's called feedback. Is it correct? Any other answers? Does anyone memorize anything? Hopefully, through this course, you will also be able to adjust some of your understanding in power electronics in terms of control before. If I draw a picture, you would be recalling what you have learned before. Okay, so let's see. If I draw a picture like this, control block diagram. Okay, and then in this picture you would be able to find this is a controller. Okay, this is the main circuit. Because the controller taking commanding signals and then send out control signals to control the operation of the main circuit. Now, the measurement of signals in the power circuit has two possible ways of signal flow. Two possible ways of signal flow. One way is that when you measure a signal in the main circuit, and that signal through the structure of the control system. Okay. Here is the structure. Okay. Other than the main circuit, the rest of the power converter is the control. if you measure the signal in the main circuit, and the signal flow is forming a loop, closed loop. That's called feedback. Did you recall? That signal flow follows a loop. That's called feedback. But if you measure the signal in the main circuit and that signal flow does not follow a loop, then that's called feed forward. For example, if I measure the signal in the main circuit, I send it to over here, controller. Okay, and this signal, let's see, you measure, for example, the load current I/O, load current. Okay, and that signal measure and send to controller, and you adjust controller adjustment, send to the main circuit. In the main circuit, that does not affect I/O at all. Okay, then that's called feed forward. Based on the signal flow diagram. So let's take a break and you think about this. Feed forward and feedback.